All right, let's now get started. I'll get to the new lecture in just one moment, but let's now do the usual routine. Reminders. In the coming reading week, my office hour will be a little bit different. I'm going to reach out to you by e-class announcement. I'll try to make some time for you guys. So you can maybe talk to me about lab number 2, which you should really get started. That'll be a very good preparation for your programming test number 2. That's also coming after the reading week. And if you want me to go over your answers about written test number 1, you can also drop by the office hour. And then if you got any other question more in general, maybe for example OOP reviews, after completing the programming test number 1, if you would like to talk about certain gap in your concept or maybe skills for Java programming or OOP in general, speak to me and then we can work out maybe some suggestion about how you may proceed with this course. And there will be a bonus opportunity coming up. So what I usually like to do is to ask you guys some anonymous, like a midterm course survey by e-class. So basically you can just say whatever you like. You can, if you like about this course so far, let me know about it. If you don't quite like about it, also let me know. If there's any suggestion I can incorporate, maybe after the reading week, I'll try. If no, maybe you'll benefit, maybe future students. That's kind of the idea. But the bonus opportunity will be if the collective response rates between both sections go above certain threshold, then we can get some bonus for everybody. But anyway, I'll reach out to you either tomorrow or maybe early next week. Okay, you can look forward to it. Do you guys have any questions about the course so far? And by the way, for your programming test number 1, I will reach out to the TA pretty soon about the grading, and then I'll hope to get back to you by the end of the first week after the reading week. Okay, that will be the idea. I'll give back to you the results and the feedback, and then I will also schedule some special hours if you'd like to go over your programming test 1, maybe feedback. Okay, so we'll do that. For sure, you get feedback before your programming test 2. All right, any questions? Yes?
Will you receive the programming test points in every file?
No, actually, we wouldn't really reveal the like a test file or source file. But I would say if you want to get some specific feedback related to your solution, just drop by. I can load up your submission. We can take a look. That'll be the way. Yeah. All right. OK, I'll give you more details once we release the result for programming test 1. But at the same time, you know what to do, given the reminders. Let's have a very quick recap about what we finished on Tuesday. And then today we can move on to some different subjects, but it's also exciting. All right, so last time we actually talked about the basics of JUnit tests, right? The important thing is remember, if you don't have anything in a single test, meaning that no assertion failure, also no unexpected exception, in that case, it will just be a pass automatically. So you gotta watch out for the quality of your test. And this will be some exercise for you just to get used to the basic assertions, and we'll get to these also today as well for exercise. And the tolerance for comparing double values, and that's the example we did about what if an exception is not expected? How should we organize the test case, right? We talk about rationale, and then that's the kind of detailed tracing, and then we also talk about the special case where we got 2 try and catch blocks, where we actually try to say, well, what about in the first phase, the exception is not expected. But now in the second phase, we got the exception expected. It's kind of flipped, right? How should you organize the test accordingly? And we talk about both phases and how to structure them in detail. So you may want to refer to them during the reading week. And then we spoke about 2 exercises. The first exercise was about what if we don't really use any assertion. We just use print line as the pass or fail for your test case. We talk about its limitation. And the second exercise is to say, what about we mix all the call to the increment, for example, in a single try and catch block as opposed to 2? And what's its drawback, right? Also, you want to also review that, make sure you really understand. If I give you something similar for multiple choice or something similar for written answer in the final exam, I will expect you to really answer. Okay, so review them. If you really find you're not so confident with your understanding, just drop by, right? We can always check. And the last example we spoke about last time was about some useful application of for loops, or you can use while loops if you wish. Basically to say, rather than writing multiple assert equals or method call, you can actually use the loop to actually automate the process, especially if the counter values are having a very large range, right? In that case, it could be very useful, right? You can start applying them also in your labs when you write additional test cases for your software. It's recommended. All right, that's basically what we spoke about last Tuesday, 2 days ago. So do you guys have any questions about what we spoke about? JUnit test, regression testing, and also organizing your test depending on what the expectation is. All right, hopefully everything's clear. And let's now move on to a new lecture, and which will be about object equality. All right, let's talk about from scratch. Okay? So the plan today, I would like to show you some very important tracing, very simple tracing I will encourage you to do, which I'm going to demonstrate to you on the remote lab, which is going to use some debugger to show you why equals method is so worth our attention, number one. Number two, I'm going to show you how you can automatically generate the equals method in Eclipse. And then when you see the generated code from Eclipse, it might seem quite puzzling about the code structure there, which I'm going to go line by line with you. Okay? I'm hoping to get as far as I can, and then I'll try to end in the same place that I did for morning section. We'll see how that goes, but don't worry. If you got any questions, as ever, just interrupt, because things could be a little bit heavy towards the end. So we'll see. Okay, let's go over. So what should we learn in this lecture here? Object equality. And it's really about whether you want to override or not to override. That's really the design decision you want to make. There's no right or wrong. If you choose not to override, that's okay. If you choose to override, that might be okay too. So it's a matter of you want to know what's the consequence of doing either one. And we're going to talk about assertions that's related to equality. Most likely this point will have to be discussed after the reading week, but that's something we'll see as well. To distinguish between assert same and also assert equals. We'll see some assert equals, maybe not today, sorry, maybe after the reading week, but it's there. And then we're going to review these two guys, the logical operators, especially there's something called short circuit. If you are already familiar, that's good, but otherwise we should talk in detail about these two guys because the way you define the equals method may depend on them. So that's something we want to see too. And finally, I'll give you some slightly more complicated example for comparing the, for defining the equals method, especially if you got array attributes in your class, like in our programming pattern. And this will be very useful for your lab number 3. Not yet, right? So you will just come in time. All right, let's now talk about equality. Let's now go over some slides, pretty brief, and just to make sure you recall the detail. And for this one here, let's just go over a slide very quickly. For primitive variable, they simply got some value. For example, integer, double, right, primitive. And for reference variable, any time you declare the type to be a class, either the class is from API or from your own definition of the class, it's going to store the address. We can get P1, we can get P2, and then, now here comes the thing. Whenever you say equal comparison, you can say equal for primitive type. You can also say equal for reference type. Now you want to know what the difference is when they're comparing. All right? Let's now review. When you say primitive, if you say, for example, D1 over here equals D2, you're comparing 7.5 and 7.5. Okay. On the other hand, if you try to say P1 equals P2, you're basically comparing their address value, right, as we emphasize in the review. So that one is not new. I just want to remind you. You want to know that equals is applicable to both primitive type and reference type. You just have to be clear what they are comparing exactly. All right? Any questions so far? Just recall. Alrighty, let's now move on. The next slide here is important, okay? So here, unavoidably, I have to talk slightly about inheritance, but I wouldn't touch too much. As I promised, I'm gonna focus a lot on inheritance for this course. That's something you deserve to know in detail. That's something we'll do possibly from lecture number 3 after the reading week. But for now, let's do something very light, Okay? So there is a class in Java called object class. All right? It's a class whose name is objects. And that class you have no control over. It's just there. All right? And now let's see where this object class comes to play in our object equality. So what I want to show you is this. I want to lay out something on the paper from scratch, so you will see what we're trying to do. What I want to do is, let me now declare some class called point v1. Class point. And I call the v1 standing for version number 1. I'm later on going to have point v2 as well, not yet. In this class here, very standard, let me say I got integer attributes x, integer attribute y. And then I have some constructor over here, point v1. That one there is going to take, let's say, integer x and also integer y. And it will just do what you can expect to do, right? Assign. That's good. Let's say that's it for my class. So the only method or constructor I have for the class is point v1, nothing else. Let's not even worry about get x, get y. Right? We only got this one here. That's the whole definition for point v1. Let's now imagine I'm trying to test this code over here as follows. I'm going to say point v1, p1. New, okay, I'm going to call the constructor, okay? And also point v1, also p2, just another point v1 objects, right? That's a new keyword, just call the constructor, right? Now, if I say I want to print out some result, let's say print line, and I'm going to say the following. P1 dot equals P2. And this should be new for most of you, because so far in the course, at least in the tutorial and labs I showed to you, the only occasion where we use the equals method is in the string class. But now we're using it in the point v1 class, right? That's something new. I have a question for you to begin with. Question number 1. Does this compile? Given that the equals method is not defined or declared in point v1 class. Let's now answer question 1 first. Does it compile? Well, for those of you who know, you will know that it compiles, right? But you might be wondering, because according to what we have learned so far, you should only call a method on the context objects if the context object's type, in this case point v1, has that method, right? But now, this one compiles, meaning that equals method does exist somewhere. Yes, it does compile, even though the equals method is not declared in point v1 class. That's number 1. All right? Number 2, follow up. Where does this equals method come from? Right? Where does the equals come from, given that it compile? Big question. All right, I'm going to tell you the answer. Oh, maybe you're going to say object, right? I'm pretty sure. Yes, correct. That's why I mentioned object, right? You know, everything has a flow, right? Nothing is random. And I'm going to show to you, right? Object class. Right? Hopefully you can see what I'm trying to get to you. I'm saying that the equals method somehow is available to a class where the class does not explicitly declare the equals method. Okay? That's the important point. And let me show to you. I already made the source code available to you guys on the lecture site. Please check it out. But this will be the demo which I think I should really do it together with you. And I would suggest you try to reproduce. It will only take about maybe 30 seconds of your time. Okay? Let me show to you. So if you import that project on the lecture site, it's called example equality points persons, whatever. Okay? If you open that, go to the points package. And so here, let me remind you quickly. So for the point V1, that one is exactly what we said, but I just adding get x, get y. Doesn't matter. We just don't have equals method, right? You can see in this class here, right? That's it. We don't have the equals method. And if I go to this tester code over here, which is JUnit test, what I'm going to do is I put a breakpoint here in line number 19. That one there is trying to say P1 dot equals P2. And let me remind you, P1 over here was declared as point V1, which does not declare equals. Remember? All right. Now, what I want to do is let's pause the execution there and step into and see which equals is being called. All right? It's important for you to see that and also convince yourself by doing it yourself too. All right. So we put a breakpoint here in line number 19. And I'm going to launch the debugger over here, and let's switch. Now I'm pausing at line number 19, right? Oh, sorry. Let me just go a little bit more aligned. If you can see that in line number 19, when we try to step into, we're going to step into this equals method here. Okay? Let's now step into. And as soon as I do that, see where I switch to. I switch to the object class, right? Object class is part of Java API, in which case I can also go over it. And in the equals method, in the object class, they have only a one-line definition for the equals method. Sorry, wrong way. And this definition here is also on the slide. It simply says return this equals obj. Given that we're talking about reference variables right now, so it's only comparing addresses. So what does that mean? Let me summarize. Right, so that's something I will suggest you do also to convince yourself. Okay? What we have seen is two things. Number one, the equals method, if your class doesn't really have the default version, it comes from the object class. Number two, the equals method there defines just by reference equality. Okay, two things. And let's now summarize this in here. So we have the object class that's in Java API. They also got other things in the same class. For example, hash code, toString, but we don't need to worry about them. We only worry about the equals method. And of course, you can do some very basic check. It's a method which returns a Boolean. It's an accessor. And over here, the parameter takes another object. That's something we'll get into a little bit later. And then it's simply going to return this equals obj. So this will be reference equality. Just comparing addresses. Compare addresses between the context object this and the obj. And now let's see the layout for the lecture. Okay? You can see we got our point V1 here, which has no equals method. So what we should really note is this. Number one, this class over here does not declare. The equals method. Number two, if it does not declare it, the technical term to say is it's going to use the inherited version from object class. I'm going to write it down. It's going to use the inherited. A little bit like, it's, again, it's an analogy from real life. Like we inherit maybe some attributes or some fortune from our parents, like inherits. Use the inherited version of equals from object class. All right, so this is really important for you to know from the object class, which is exactly here. All right, that's the version we're going to use. So whenever you want to invoke the equals method on point V1, you're always going to see that version equals. That one boils down into comparing addresses, which we'll see. All right. On the other hand, what we're going to see also later today is we can have another second version of the point. I call it point V2. All right? That one there goes like this. You can see we still got the attribute x and y. We got the constructor here. And then this entire thing is the equals method. You can see here, Boolean equals obj versus Boolean equals obj from the object class. They are the same, right? In the case where you got two methods, somehow they got. So for the extents over here, it's something to say about inheritance relationship, which we don't have to worry too much right now. But just remember, whenever you see the extents keyword in Java, that means inheritance. By default, every class you define in your package, they inherit from objects. You have no choice. It's just the case. All right? And now in this case, the equals method is somehow, we say, overridden or redefined in the child class over here. So we say this will be the, okay, let me write it down. We say that point V2 over here is a child class of the objects. Symmetrically, we say the object class is a parent class of the point V2. Similarly, for point V1 as well. All right? If you repeat the same inherited method in the child class, that means you're doing something called overriding or redefinition. Okay, here. This is trying to overriding or redefining. I thought redefining just give you a little bit more intuition. We're just redefining something that's already there. But the Java term, the more technical term, just saying overriding. Okay, whichever way you like. The inherited equals method. Right? It's important for you to see that, right? Overriding, redefining the equals method. All right? And that method there looks complicated. The entire thing, from here to here. Right? We're going to talk about its detail line by line in just a moment. But before I do that, I want to show you one thing in the Eclipse as well. In Eclipse, you can, let's say in the beginning, when we first define this point V2 class, let's say we don't really have this equals method just yet. You don't really have to type it out on your own. You can use Eclipse to generate it automatically for you. I'm going to show you that. Okay? You might find it useful for your lab number 3, okay? Which is totally okay. So let's go back to the Eclipse over here. Right? Let me, I think the debugger has been stopped. That's good. How do you generate the equals method? Oh, actually, I should stop it. There we go. Let's now go back to point V1. Okay, let's say now if I want to create, generate some equals method for point V1, let's say if I want to do that. Basically, you're just going to move the cursor outside any method as if you're going to define a new method, as if, right? Right-click, and then you're going to go to somewhere at the bottom there called source. And then there is one choice over there called generate hash code and equals. For this course, we don't really talk about the hash code method. It's not applicable. We might talk a little bit about hash table, hash code, maybe in 2101, but not in this course. So I would say when we generate these two methods, you can always disregard the hash code that's being generated. All right, let's see how we can generate the equals. Pretty straightforward. If you click on that, and the list over here are all the attributes that you could potentially, the attributes here are the attributes you can choose to potentially include into your equals method definition. But I would say by default, you can just choose everyone. That's okay. And nothing else for you to customize, right? You can say where exactly you want to generate it. Doesn't matter. Okay, let me say generate. And this part over here is exactly generated for you. And if you generate by using Eclipse, it's also going to attach a override tab there. You can just keep it there. That's okay. And this definition here matches what I'm going to discuss in the lecture. We have to learn and study this method here line by line. Okay. All right, any questions so far? So we kind of already show you many things, right? Just to smoothly move you towards the discussion for equals method. You want to know when are we going to use the default version and when are we going to use the overriding version, like here. All right. All right, so that will be enough for Eclipse illustration for today, but that's something I'm hoping that you also try yourself too. And let's see anything else here. Yeah, superclass, parent class, so please just get yourself familiar with the terminology. And also object class, and that's an equals method, default version that we talk about, which boils down into comparing just references. We're going to do exercise right away before we see the overriding. And so that's really the redefine or overridden, right? That's just the spelling. Just make sure you're right. Right, so that slide is good. We covered that. So I would like to, so there's a common error over here I want to mention. If you got primitive variables, let's say I and j, it would be wrong if you say I dot equals j. It just cannot. Equals method is exclusive for reference type. You cannot apply equals method on the primitive type. All right? If you do that, it's not going to compile. That's something to note. And we're going to just talk about point V1, and we're going to see how we can manipulate the default version of the equals method. Let's see that first. And then we're going to take a look at how the overridden version is going to be different. Oh, we'll take a look. All right, so now we are focusing on this point V1 class, right? Point V1. You can see attributes and also constructor. No no explicit overriding or redecoration of the equals method. That means we're always going to call this version instead. Let's see how that's going to happen. And we got some piece of code over here that's going to illustrate various things. Let's do one by one. Line number 1, we have some string objects S. Okay, you can think about S is simply pointing to some string objects 2, 3. So this will be enough for now. You can even draw the box if you want to, but we don't need to for this example. And for the next 3 lines, 2, 3, and 4, we're basically creating P1, P2, P3, and then using the constructor, right? P1, 2, 3. P2, 2, 3. Also P3, 4, 6. Easy. And we're going to do various print lines just to see how the Boolean expression is going to evaluate. All right, first one. What is P1 equals P2? False, right? Good. Pretty easy. Different objects, right? P2 equals P3, also false. Pretty good. And now let's see how the equals method is going to play. All right? When we call, for the very first one, let's discuss it in detail. When I talk about this guy here, okay, I'll put a star. Okay? Let me put it here. I got P1 dot equals P1. Okay. Now, how the execution goes is like this. The Java runtime is going to look at the context objects, P1. And then P1 is here. It's going to look at which object specifically is P1 pointing to. In this case, it would be point V1. And then, given that it's pointing to a point V1 object, we know that the equals method should come from the point V1 class. However, there is no explicit declaration of equals method in point V1 class. What we should do instead is to go to its parent. In this case, objects. The object class has the default version. So that will be the one we want to use. Let me say it again. Every time you're calling a method in Java or in any OOP, we should really look at what type of objects is the context objects at the runtime at this point. In this case, P1 is pointing to point V1 objects according to our tracing. So now the Java runtime would know we should really look for the equals method in this particular class. But there's no explicit definition of the equals method in this class right now. By default, a little bit like a searching for something, right? We're going to search for its parent class. Does its parent class have the equals method? It does. So this will be the version to use. Okay, that's the process. So what I can write is no explicit equals in point V1. Instead, use the default version in the object class. So it will end up calling this method here. Any questions so far? All right. Now let's move on to tracing. When I trace P1 dot equals P1, the context object is P1. I can replace every occurrence of this by P1. And you can see the parameter or argument is P1 as well. I can replace every occurrence of the parameter here by P1, right? That's how we did the tracing earlier. So this P1 dot equals P1 method call will boil down into P1 equal P1 because we are applying the default definition of the equals method from the object class. All right? So this one here will simply boil down into just P1 equals P1, which is going to give us true. All right, any question here? It is really important. It requires quite many details over here, right? You want to know which version is it going to execute, and once you execute, how do you trace it, right? And the next one, what about P1 dot equals null? True or false? False, okay, but I agree, but let's see why. If you do the detailed tracing, again, we're going to execute that default version, and now this time, this will still be P1, but now the OBJ, the parameter, will now be just null, and just null, right? They will boil down into P1 equals null, which will be false, as you correctly said. All right? The next one is kind of funny, because let me highlight it, and then I'm going to show you something on Eclipse, which I promised I wouldn't, but now I need to show it. Okay? Let's now take a look at this line. P1 dot equals S1. Remember, P1 dot equals S. Okay? You can see S is a string. P1 is a point V1. Intuitively, that should be false, because you're basically comparing banana with apple. How can they be equal? They're different objects. One is string, the other one is point. But first of all, let's see how this is going to be executed, and then I'm going to show you something a little bit different. So let me call this star star. I'm going to put it here. When I say P1 dot equals S over here, and this will boil down into, the equals from the objects, right? Which is going to do P1 equals S. But now, I would like to put this one into quote. It doesn't mean string. I'm saying that conceptually, that's how you should think of it. We're basically comparing the addresses between P1 and S. And that one should be false, of course, because you can see P1, this object, S, this object. They are different objects. Of course, they got different addresses. And now let me explain the quote part. Quote part means you only want to think of it conceptually. You never want to write this expression here like a P1 equals S explicitly. It's going to cause compilation error. I'll show you. Okay? Let me write it down first. And there's a note over here. Writing P1 equals S is going to give you compilation error. Because you're comparing the addresses of two different objects. Eclipse doesn't like it. It doesn't even want to execute it. All right, let's now show this to you. If I go back to my Eclipse, okay, I'm just going to add some line just to show you. Oh, you know what? Let me just get rid of this default equal, which I don't want to pollute point V1. All right, this one is one I want to show you. All right, guys, I want you to look at this fragment over here, which I just commented out for now. Just give me one moment. Oh, maybe I deleted that. Okay, I'll just write it down. We got point V1 over here, right? So why don't I have the following? I'm not only worried about compilation. So let's say I got, oh, you know what? Let me show it here right away. Okay, I got P1 here, right? Let's say I got some string objects. S would be 2, 3. Right, I got P1 and I got S. Let's try 2 lines. If I say system assert is okay, or is it system the other print line? Let's say assert true. Doesn't really matter. Okay. Let me say print line. That'll just be simple enough. System out dot print line. Okay, I'm gonna do 2 things. There'll be this will be the first, and this will be the first. This will be the second. Right. The first thing, if I say P1 dot equals S, as you can see, line number 13 compiles. No red underline. On the other hand, if I write down that definition from equals method default version explicitly, P1 equals S, red cross, right? Let's now read the error message from Eclipse. It says that incompatible operand types, point V1 and string, that makes complete sense. P1 over here was a point V1 object. S over here is a string object, in which case you just cannot even write equal to compare them. However, the reason that you could say P1 dot equals S, this one is okay. The main reason is because over here, if you look at the declaration for the equals method here, it says that whenever you want to pass an argument to the equals method, you can pass anything. Object class simply means you can pass anything. It can be a string, can be a log, could be a assessment, can be a grading components, right? Whichever you like. Right, this is a subtle detail here, but that's important to note. When you say P1 dot equals S, it will compile. It will boil down into comparing their addresses. However, if you just try to compare the addresses explicitly and directly, it's not going to compile, right? It's something you want to notice. All right, any question here about this? Yes?
So there's going to be like no one error.
You mean for this one here?
Yeah, yeah.
This one, no. Because that, okay, good. So this one is going to compile. So if you try to execute it, it's simply going to return to you false. So there'll be no runtime error. And to see why this guy here is going to give you false, for example, we're going to see the definition for equals method when we get there. Okay. Again, if you write this, it's going to have compilation error. So let me just make it more explicit. No. All right, any question? All right, hopefully that's still clear. All right, so what we should do now is we should talk about the overridden version quickly, right? So there are, so if you look at the overridden version, so that one there is declared in here, point V2, all right? So we got 1, 2, 3, and 4. Oh, 1 here, 2 here, 3 here, and 4 over here. We got 4 different phases to discuss. I'm hoping to get to maybe phase number 3 or so, or maybe just phase number 2. We'll see. Okay? That's something I'd like to do. Why don't we do phase number 1 or 2 very quickly? Okay? So for phase number 1, we say that if the context object is simply just equal to OBJ, what does that mean? That means if the context objects and OBJ, they are simply equal to the same objects over here, conceptually, and then the equality should be true. So when you make a call, for example, if you say P1 dot equals, let's say something over here. If it turns out P1, which is this, dot dot is like an OBJ. If they point to the same objects in that way, this whole thing here should really return true because they are the same objects. Right? That's the first number, phase number 1. Right? Let's now take a look at one example right away. So let's now take a look at this. Okay? So we have, again, our friend, the string object, but we don't need it just yet. So let's say we got V1, V2, P1, P2, P3. But now they are point V2, right? So P1 here, 2, 3. P2 here, 2, 3. P3, 4, 6. Right? So P1 equals P2, yeah, false. P2 equals P3, also false. They are easy. All right? So now let's take a look at this line here. P1 equals P1. All right? When we say P1 dot equals P1. Question number 1. Which version of the equals method are we going to execute? Because right now, notice that this is the version of the equals method that's declared in point V2. This is the default version that's declared in objects. Which one should we go to? Right? And remember the decision procedure I just mentioned. You should look at the context objects. So P1 over here, the context objects, it is currently pointing to point V2. That means you have to go to point V2. Does it have an equals method already? It does. Exactly over here. So that means we are not going to be bothered by the default version. It's not relevant anymore to us. We're going to use the overridden version of the equals method. And when we trace into the code, let's see. Let's see here. So P1 that equals P1, right? So that means the OBJ here is simply just P1. OBJ here is simply P1. And also the context object P1 here is this. So now it really boils down into if P1 equals P1, and then it's going to return true. Is P1 equal to P1? Is that true? Yeah. An object is equal to itself. I mean, reference. I mean, they have the same address. So this is going to be executed, and then it's going to return true. Right? This tells you P1 that equals P1 is going to return true. But this one seems too simple, right? I'll give you another example here. Let's assume after line number 4 over here, let's say we got another point V2 objects. Let's say we got point V2 that's called a P4. And P4 is simply assigned to P1. All right? You know how to trace it. P4 pointing to where P1 is pointing to. Now we got aliasing. P1 and P4. They point to the same objects. Now, if we try to do equals, P1 dot equals P4. If you just by looking at the line, P1 and P4 seem to be different variables, but the nature of these two variables are they're referring to the same objects. So if you try to trace down the code, P1 is now still the, P1 is still the context object. So you still see P1 as this, right? And now if you try, let's say the argument P4, so obj here will be P4. And the obj here will be P4. So it really boils down into if P1 equals P4, and then you're going to return true. Now, is P1 equals P4 true? It is, because you got P1 and P4, they point to the same objects, right? So that's why it's going to return true. All right? Any question about this? Okay, if you feel lost, you should really speak up. Otherwise, I'll assume you're fine. Out of all four phases, phase number 1 and 2 are quite trivial, but I think it deserve our attention just to see how things should be done. Okay. Any question? All right, I assume everybody's okay, yeah? Why don't we do phase number 2 very quickly? Okay, for phase number 2. Okay, let's take a look at phase number 2. Now we say if the parameter objects we are passing happen to be null. That way, we're just going to return false. All right? Let's now go to phase number 2, right? That's the line we are focusing on. One thing for you to note right away. This if statement is checked first. If that one happened to be true, we just return true. If we are able to reach this line, what does that mean? That means the condition here will evaluate to false. Agree? Okay? So a note for you. Reaching this line means this is not equal to obj. That means they are not the same objects, but they might still be equal to each other. Maybe their contents are the same. All right? So what we're saying is, reaching this line, we know that this and also obj, they are actually pointing to different objects over here. But we got to dive a little bit deeper into how they are different. Or maybe they're just equal. And now we're saying the following. If the obj happen to be null, let's say rather than this, let's say if we got this following scenario. This is this object here. Obj is simply equal to null. In that way, conceptually, we're comparing something here and something that's null. So we should return false. Right? That's basically the rationale behind this phase over here. And let me do one example right away, and then I have a little question for you. If I go for phase number 2, and then let's say I got to this point here. P1 equals null. Sorry, P1 dot equals null. All right? How do we trace this line? All right, line number 8. So now P1 will be the context object this. So this will be P1. And then, oh, that'd be good enough. And then we got null will be the obj. Right, like that. How do we trace the line now? When we get to this line here, P1 equals null. False. Agree? Because P1 does point to some object here. There, it is there. So this evaluation is going to be false. So that means we'll bypass the body of the if. And then when we go to here, obj equals null. True. Because obj here is really, okay, obj is the argument, right? We should have replaced that by null. Now if I say null equals null, it will be true. That means we're going to return false. So what we are really saying over here is as follows. We are saying that If you're comparing the OBJ, in this case, it would just be null. Are these two objects equal? No, because one is not null and one is null. Okay, that's one example here. But I do have one question for you here. Have we missed a simple scenario here? Because, for example, let me go back there, phase number 2. I wonder this. Let's say maybe this is pointing to null, and also OBJ is also pointing to null. In that case, null is equal to null. Then they should be considered as equal. All right? So accordingly, I'll take a question a little bit later if you still have one. So what I want to do now is I'm going to suggest one alternative to this. And I want to ask if you agree if that might be a better way to express our intent. Okay, I'm going to put the alternative over here. The alternative goes like this. We're going to say if OBJ equals null. And I'm going to further divide the cases to say if this is also equal to null. In that way, I'm basically comparing null with null. So I should return true. Otherwise, if this is not equal to null and object is null, I should return false. All right, so you can see here. So when I'm comparing null and not null, I'm still returning false. So this case is still covered. I'm just adding one case where I say I got OBJ equal to null, but this also equal to null. In that way, I'm going to return true. Right? My question to you is this fragment of code sensible? Does it really make sense? Guys, this requires some very insightful observation about what's happening here. Especially for those of you who may not have a clue just yet, I want you to pay attention to this case. Is it ever possible we might go into here? That's a question. Big question. All right, anybody would like to speak out? I'll just take one. Go ahead.
So for this object would have to be instantiated in order to have a memory address in order to invoke this method. If it's not instantiated, then it will not be invoked. There's no object.
Okay, if there's no object like a null and you invoke a method, what's going to happen? Not really. So, for example, if I say, not compilation, but you're really getting somewhere. If I say something like, if I got, for example, point v2, let's say p5 equals null, let's say. If I say p5 dot invoke, let's say some method, let's say get x, for example. It's going to compile. That's what I wanted to hear. It's not compilation error. All right? So why is this relevant to our discussion over here? Null pointer exception. Now, when we go back to this branch over here, are we ever going to reach this line here? Okay? Now here's the answer, right? For those of you who already thought about it, that's good. The reason that we only have to consider OBJ is equal to null here is because if you're able to reach this line, or even the first line of this method here, that means that this cannot be null. If you try to invoke, let's say, p1 dot equals something, and the context object this happen to be null, you're not even going to be able to execute the method because this is going to be a null pointer exception right away. You don't even get there. All right? That's something I would like you to think about, right? It is very important takeaway to see why the phase number 2 is this simple, just a single line over here, as opposed to this over here. Because we know that at this point, this cannot be null. This cannot be null. Right? So important here. All right, any question about phase number 2? All right, so before we talk about phase number 3, I think we got about 25 minutes for today. And there's a little convention I like to do usually for 2030, before the reading week. I would like to play or show a magic trick before we move on. All right, that can wake you up maybe a little bit. All right, let me do the following. To do the magic trick, I would need 2 assistants. 1 boy, 1 girl. How about that? Anybody would like to volunteer? I just need 2 assistants. 1 boy, 1 girl. How about boy? Here. Okay, how about 1 girl? Don't be shy. Please come on to the front. All right. Now, I want to really make sure this is done completely randomly. I didn't really talk to your classmate beforehand. It's really a magic trick. All right? So now, good. Thank you. Okay, before I decide who's assistant number 1, assistant number 2, do you know rock, paper, scissors?
Yeah.
Why don't you play? And see, winner will get assistant 1. Assistant 1. Okay, very good. Okay. Assistant 1, now, what I got here is a class of Java code I wrote, and then I'm going to run it as Java application. Okay? And the program is going to keep running without stopping. Throughout the trick. Okay. Now, what's your name?
Elvis. E-L-V-I-S.
Good. Okay. This is how the trick is going to go. You know poker, right, guys? Elvis is going to choose 1 card from here. And he's going to let everybody in the room know except me. I'm going to step out of the room for just a moment. And then my assistant number 2, when he has done choosing the card and let everybody know, you got to call me in. All right, good. And for example, you can maybe just briefly highlight or just have a way to let everybody know. But just make sure when I come back, I don't know which card it is. And the program is still running. All right, don't take too long. Okay. All right, done. Thank you. All right, everybody knows what the card is, right? Don't let me know. All right. All right. Before I move on, can I just clarify something very quickly? So we're gonna do by like a column, right? Let me explain quickly. So you're gonna tell me which column it is, right? Column like a vertical line, not horizontal, right? Otherwise it wouldn't work. All right. So now I will need to ask you and everybody 3 questions.
Okay.
All right, simple question. Question number 1, which column is your car?
Number 3.
Number 3, are you sure?
Yeah.
Okay, you're talking about this column here, right? Okay, just to be sure. Okay, I shuffle the card. Now tell me which column it is.
Number 2.
Number 2, everybody agree? Okay, number 2. All right. Last question, which column is that? Number 2 still? Now, I know which car you chose. Guys, magic. All right, thank you so much. All right. So this is not really done to you just completely randomly. So usually I like to give this right before the reading week is because somehow it looks like a magic. But the reasoning behind is just math. All right? A little history about this puzzle here. So do you know Professor Jeff Edmonds? So he used to teach me when I was a student here back in 2004. Maybe you were not even born. So I was taking that 3101 algorithm course from him, and he was showing the same trick by using physical poker card. So when I started teaching this course, I thought maybe it'd be cool to turn it into Java program. So that's why I'm showing you here. So what I want to propose to you is like this. If you want to maybe try some challenging example in programming in Java, this could be one to go. Okay, let me tell you if you're interested. Again, this one, no bonus mark, no extra marks, only if you're interested. Okay, what you should do is this. I'm going to make this link available to you. And this is a place where they show kids how to do magic card tricks. Right? So this one here, they're going to show you how the trick actually works. Okay, how to shuffle the card and how to choose the card and etc. So I would say during the reading week or sometime beyond the course, beyond the reading week, so you can try this out. The solution is going to require quite sophisticated manipulation of the loops and array. I would say give it a try, and since we learned about OO modeling, you can also try to create different classes to model maybe magician, assistant, card, deck, whatever. Okay? And once you're done with your solution, I'll be happy to see it if you want to show it to me. And then I can go over your code and give you some feedback. All right? Anytime before the end of the course. So that'll be it, and I'll make this link available to you. All right? And before we, let's see, we got 20 minutes or so. Why don't we take a 2 minutes break, and then we'll come back to the contents. All right, so before the reading week, I'd like to get just the following example done. In order to really study phase number 3 and phase number 4 for the equals, there is a need for us to understand certain things called static type, dynamic type, and cast. That's something I'll go through today. But just to let you know, if you look back to the equals method, what's left to be discussed is phase number 3 over here, and also phase number 4 over here. I'll leave the concrete example to after the reading week. But it's more important for me to introduce the necessary background knowledge to you in order to understand these two. But we'll come back to these two after the reading week. But for now, I would like to go over this example in detail with you. And what you got to do is during the reading week, struggle through this example a little bit to really understand as much as possible. And I have to emphasize that static type, dynamic type, and casting, they are to be discussed 100% when I talk about inheritance. For now, I don't want to get too deep into that discussion. So I will only cover maybe about 70%-ish. But if you do have questions to clarify, you can ask me. But if that's something a little bit too much for now, I will let you know. But understanding this example here will be enough to understand the equals method. All right? We are going to learn 3 concepts over here from this example. Static type, dynamic type, and typecasting. 3 things. All right? Let's go over one by one. Static type, by definition, simply means whatever declared type it is for a reference variable. For example, O1 has a static type C1, and O3 has a static type objects. Once the static type is declared, it never changes. Never, ever. There's no way for you to change it. Okay? Dynamic type over here, by definition, is the address that's currently stored in the variable. Meaning that if I have, let's say, P1, for example, it is now pointing to some objects over here of certain type. So we say that this is now the dynamic type for P1. Later on, if I redirect or change the arrow of P1 into another object over here, now this will be its new dynamic type. All right? Good. So that dynamic type can change all the time. That's something we're going to see, how to manipulate it. And typecasting over here, we'll see that when we need it. It's basically to say, I want to create some expression temporarily. And that expression can contain the static type I need. All right? One more thing to say, and which I'm going to make a note over here. For static type, it determines the range of methods you can call on the context objects. If a context object is of certain static type, it determines the range of methods applicable on that context objects. All right, that's definition, but I'm going to show you an example. All right, let's now make a very simple setting here. We got C1 and C2. C1 only has one method called M1, and C2 only has one method M2. And the obvious thing that's implicit here is the object class has no knowledge or is no declaration of M1 and M2. The object class is already there. It's always fixed, right? It's not going to have M1 and M2. M1 and M2 are only specific to their corresponding C1 or C2, right? That's our, not really assumption, it's just a fact, okay? Let's now try to understand this. The first line over here, when I say C1, O1, new C1. Here, after this, I know that the static type for O1 is just its declared type. Dynamic type is basically the object that's being pointed to, happen to be the same. The way to visualize this is O1 is basically pointing to some C1 objects. Think about the C1 over here, the title of the box is the dynamic type. Dynamic type. All right? And right now, static type and dynamic type, they happen to be the same, which is pretty much the case you have seen so far. But in general, it doesn't have to be the same. All right? And we go to the second line. C2, O2, new C2. So now after this line here, we know the static type for O2 is C2. Dynamic type for O2 is C2. Also the same. Think about we got O2 over here is pointing to some C2 objects over here. Right? You can see the C2 over here is the dynamic type over here. Also happen to be the same. Okay, so far so good. Let's now try some method call. Whenever you're seeing some method call, let's say for O1 over here, the context object is O1. In order for me to judge whether I can make a method call M1 or M2, I need to look at O1's static type. Okay? So now we know that O1 has a static type C1. That means I can only invoke M1. So now if I say O1.M1, compiles. If I say O1.M2, does not compile. Because the static type C1, right, does not contain M2. This is so important. I'm talking about whenever you're trying to determine whether or not a method call should really compile, you should really look at the static type for its context objects. All right? Now, symmetrically, if I try O2 over here, we know the static type is C2. C2 only has M2 defined. So I will know that I cannot call M1, but I can call M2. All right, symmetrically. And let's now move on. Let's now have a different static type. Now, if I look at this line here, over here, by declaring that, I know that this object over here is a static type for O3. So for O3 here, it has a static type objects. All right? And then, let's now take a look. If I have O3 equals O1, what does that mean? That means I got O3 here is now going to point to wherever O1 is pointing to. After this line, question, what will be the static type for O3? The same. That never changes, right? Objects. What will be the dynamic type for O3? C1. Okay? You guys are getting the pattern here. And now, let's now try some method call here. If I try O3 dot something, the only thing I need to look at would be static type objects. Does object support any M1 or M2? No. So, doesn't compile. Even though you might be thinking that O3 is really pointing to some C1 objects. I should have M1. No. Because O3 here has a static type objects. Now, here comes the typecasting. The only way let's say in this case, here comes the motivation. O3 over here has the static type objects. However, even though it's really pointing to some C1 objects, but I still cannot call M1 because the object here, the static type, does not support it. The only way for me to change this is something called typecasting. Right? That's what you will see. If you try over here, let's say this is the casting. All right? I'm basically creating an expression. This is an expression of static type C1. Effectively, I'm creating an alias to O3. It will be as if I say C1 and O3, right? This is like an alias. It's pointing to wherever O3 is pointing to, but this particular expression here has the static type just C1. Now, I'm referring to the same objects, but the static type I can use right now is C1. So that's why calling this on M1 is fine. But now C1 does not really have M2, so I still cannot really do it. All right? This will be the video part you want to review when you go back to the study during the reading week. Let me do, okay, I got 7 minutes. That's good. I thought I'm almost running out of time. Why don't we do the next one? If I say O3 assigned to O2, I'm basically saying O3, rather than pointing to over here, is now going to point to O2. Now, important check. What is the static type of O3 right now? Objects. Doesn't change. Important. Never changes. What about dynamic type for O3? C2. Right? It's pointing to C2 right now. Right? All right. Let's now do the final thing. If I try to call M1 and M2 on O3, I cannot do it because object here doesn't support neither. Right? So what I can do now is, if I create this kind of expression here, for example, this one here, let's say O3 cast to C2. What does that mean? This one here is basically an alias of static type corresponding to the cast type, pointing to where O3 being cast, O3 points to. So we are saying that this is the alias over here, because we know O3 is pointing to this, and this alias over here is the O3 being cast to C2. And we know that this one here has the static type C2. And now C2, we know that only supports M2. So you cannot really call M1 on C2. So this is going to be not compiling. On the other hand, because now we got C2 here, but C2 does support M2. So calling M2 is fine. I'm going to go over in a very kind of, maybe a little bit fast, I agree. But I think it is important for me to just introduce this example to you before the reading week. I want you to go over every line over here to really see what's going on. You're going to need this kind of knowledge very badly to understand phase number 3 and phase number 4. Okay, we still got a few minutes. Why don't we take some questions? Go ahead.
So after the O3 to O2,
Yeah.
what happens as C1?
Yeah. So the question was, after this guy over here, if I try to cast maybe O3 into C1. Okay, I'll tell you precisely. O3 at the moment is pointing to some C2 objects, and you're trying to cast that to C1. As far as cast is concerned, it's okay. It's going to compile. But if you're casting something to something different, you're going to get something called class cast exception. But I would say for now, you guys don't have to worry about casting something to something else that's going to cause a cast exception. Just remember, always cast to the same dynamic type. For example, O3 dynamic type is actually C2. So cast to C2 is absolutely safe. But we're going to see in the inheritance lecture how we're going to decide how the class cast exception can occur. So let me write this down, and then for now, always cast to the same dynamic type, right? So that will be the principle to follow just for now. And once we follow through the inheritance lecture, you'll be clearer. We got 3 minutes. Do you have any more questions? Yes. So this whole thing, the cast is going to work because the object class is the parent class for every class, including it's a C1 is a parent, it's a child class of objects. C2 is also a child class of objects. But we don't need to go that far for now about inheritance. We can avoid it. I just want to say, just remember for object over here, we can always cast to any class. That's all we need to know for now. All right, guys, any question? Go ahead.
So we can't change the file name of the overridden, we can just practically create a new one that's...
Yes, that's correct. Okay, maybe a final remark. So guys, please, final remark. We can never change the static type for O3. So what we're doing here, this expression here, is creating an alias, another reference over here, which has nothing to do with O3. They're just pointing to the same object as O3. But that particular alias is more generous about what method you can call. All right?
We can create a new object with the same static type as the cast type that you're using on the last expression to store whatever value they want.
Okay, I think since we are running out of time, okay, I will call it a day right now, and then enjoy the reading week, and I'll handle questions after class. All right, please study this example during the reading week, okay?